lesson is all about an introduction to chemical equations. And a chemical equation is a way of describing chemical reactions. That's where we're heading in the last half of the unit. So the first thing I'd like you to do as you're following through on this video is to watch the link that's posted on today's topic. It's actually located right here in our SmartNote. I'd like you to watch that on your own. It shows a video including a couple of interesting clips of chemical reactions. I want you to think about what a chemical reaction is, and I also want you to think about what are the 5 signs of chemical reactions. Once you've watched that, come back to this video, and you are going to write down on your skeleton note what a chemical reaction is. Basically, we start with substances, they undergo a chemical change, and we end up with brand new substances. So the definition is, a chemical reaction is a process in which one or more substances are converted into one or more different substances. In most chemical reactions, this is an irreversible change. So in grade 9, we talked about 5 signs of a chemical change, and these are them. We can have a color change. This has to be a really obvious color change if this is pointing to a chemical change instead of a physical change. If a gas is produced that wasn't there before, you could see some bubbling, which is effervescence. If a gas is produced that wasn't there before, we could detect a new odor. If we're mixing 2 liquids or 2 solutions and suddenly a solid is formed, that's called a precipitate. That's a sign that something brand new that wasn't there before has been formed. And finally, if heat or light is given off, that's a sign that a chemical reaction is taking place. So one of the analogies we're going to make between chemical equations and the English language is on this page. So as an example, when we're talking English, when we're speaking English, we have letters grouped together to form words, which we combine to describe sentences, and sentences describe something. So the analogy extends to chemistry. We start with elements. Elements are grouped together to form chemical formula, which represent compounds. That's what we've talked about so far this unit. Chemical formula are combined to describe a process in a chemical equation. So a chemical equation is like a sentence in that it's describing a chemical reaction as a process. And so that's what we're about to do. In a chemical equation, we have starting reactants. So these are reactants. These are substances that we start with in a chemical reaction. And in the process of this chemical change, they get used up. Note, we can start with 1 reactant, 2 reactant, 3 reactants, as many as we need. And finally, in our products, these are substances that are produced in a chemical reaction. There might only be 1 product, there might be 2 products, there might be 3 products. So we've got reactants on the left-hand side, we've got products on the right-hand side, and in the middle there's an arrow that represents the chemical change. These are the types of chemical equations we're going to be dealing with today. A word equation is a description of a chemical reaction that uses only words. That means we're using the names of the compounds in this chemical reaction. And a skeleton equation is a description of a chemical reaction using only the formula. So that's where we just write the formula in this chemical reaction. For example, let's say we have some water, we add electricity, and we break the water down into hydrogen gas and oxygen gas through a chemical process. This is a word equation that describes the chemical reaction. Notice how we're just using the names of the compounds or elements. This is a skeleton equation. This is a chemical equation that describes exactly the same chemical reaction. This time we're just using the formula. So that's what you're going to do today, and you're going to do for homework. You're going to write out word equations and skeleton equations for different chemical reactions. Other things to include in chemical reactions. Number 1, the state. So anytime you're writing an element or a compound in a chemical reaction, you're going to indicate the state of that element or compound. In order to do that, we use lowercase letters and we use little brackets. So here are some examples. If something is a gas in a chemical equation, we use round brackets and a little g written beside the name or the formula to indicate that it's a gas. If the element or compound is a liquid, we use lowercase l with little round brackets beside the name or the formula. If it's a solid, we use an S. That's a cursive S. The next one is a new term, kind of a fun term, called an aqueous solution. An aqueous solution means something that is dissolved in water. So for example, if I take salt and I dissolve it in water, it is now an aqueous solution. It's just salt dissolved in water. If I take sugar and dissolve it in water, it's an aqueous solution. It's just sugar dissolved in water. And when something is dissolved in water, we use AQ to represent aqueous solution. Finally, when something is a precipitate, we use PPT to represent it. And remember, a precipitate is a solid that is formed as a product when liquids and or solutions are reactant. So we're mixing liquids together, we're getting a solid, that's called a precipitate. Finally, sometimes a reaction will only happen when a special condition is met. So sometimes special conditions are required to allow a reaction to occur. If we add heat to some reactants, if we add light to some reactants, if we add electricity to some reactants, that might be the thing that gets the reaction going. So those are examples of special conditions. If ever there's a special condition, that condition is written above the arrow in the chemical reaction. So for example, when solid mercuric oxide is heated, liquid mercury and oxygen gas are produced. So in this example, heat would be the special condition. So we would just write heat above the arrow in that chemical equation. On to some examples. So for each of the following word equations, we are going to identify all of the reactants, all of the products, whether any gases were formed, whether any precipitates were formed, and we're also going to list any special conditions. So the first one says, I've got solid potassium chlorate. I'm going to add heat, and a reaction is going to happen. That reaction is going to produce potassium chloride, which is also a solid, and oxygen gas. So in this example, the reactant, and there's only one, is potassium chlorate. The products are potassium chloride and oxygen gas. In this case, there's only one gas formed. I can tell because of the state in brackets. So I'll write that here. Yes, oxygen is formed. There are no precipitates formed in this example. And in terms of special conditions, that's always written on the arrow. So heat was required in order to get this reaction going. So that's our special condition. Next example. An aqueous solution of sodium bromide is added to an aqueous solution of silver nitrate. Remember, AQ, aqueous solution, means dissolved in water. So these two substances, these two reactants, have been dissolved in water in order to mix them together. They react to form silver bromide, which is a solid, and sodium nitrate, which is another aqueous solution. So remember, I'm mixing two aqueous solutions. I get a solid, and I get another aqueous solution. The reactants are sodium bromide and silver nitrate. The products are silver bromide and sodium nitrate. In this example, there are no gases formed. There are no gases involved at all. The precipitate is actually silver bromide because the definition of a precipitate is a solid that is formed when two liquids or solutions are mixed. And in this case, there are no special conditions, so this is going to happen as soon as you mix the two aqueous solutions together. The next example, we've got magnesium chloride, which is a solid. We're going to add some electricity to it, and it's going to form magnesium, which is a solid, and chlorine gas. So in this case, the reactant, there's only one, is magnesium chloride. There we go. The products are magnesium and chlorine gas. There is a gas formed. It's chlorine. There are no precipitates formed. And the special condition is listed here on the arrow. It's electricity. That's what's required to get this particular reaction going. So now what we're going to do for the next 3 examples, I'm going to give you a sentence which describes the chemical reaction, and we're going to write a word equation, a skeleton equation for each of these examples, A, B, and C. I'm going to continue this. I want you to try it yourself, but I'm going to continue this in the next video.